If we're trying to subtract one polynomial from another polynomial, there's just a couple quick rules we have to follow that will help us do that. So let me write an example real quick, and then I'll discuss these rules here. Let's say that we had, for example, the polynomial x cubed plus 7x minus 1, and we wanted to subtract the polynomial 5x plus 5, for example. So this is a little different than if we were adding two polynomials together. For addition, you could just drop the parentheses and then combine like terms. You can drop the parentheses from the leading polynomial, the first polynomial, but there's a little bit of a problem having a minus sign here and dropping the second set of parentheses. You see, when you're subtracting an entire polynomial, you're actually subtracting all the terms in that polynomial because you're subtracting the entire polynomial. So we can drop the parentheses, but do not forget to distribute this minus sign to all the terms in the second polynomial. You don't have to do that for the first polynomial, the one before the minus sign, but you definitely have to do it for the one after the minus sign. That's a very common mistake that a lot of students make. So let's do that. We'll have x cubed plus 7x minus 1, and then minus 5x, and then a minus 5 instead of a plus 5. So that's the collection of terms that we're going to have in our answer. So in some sense, this is our answer. This is the difference of these two polynomials. But the second step is to combine any like terms that we have available. So there is only one x cubed. Here, let me bring this back up here. There is only one x cubed, but the plus 7x and the minus 5x, those are like terms. They'll give you plus 2x, and then minus 1 minus 5 makes minus 6. So this polynomial would be the correct answer. That will be the difference of these two guys. And again, just remember, when you have a minus sign, you have to distribute that negative or that minus through every term of the second polynomial. All right, now we'll close out with one more example. Let's say we had t squared minus 7t minus the polynomial t to the fifth plus 3t squared minus 8t plus 2. So I recognize this as a subtraction problem, and I'm subtracting two polynomials. First thing I see is this minus sign, and I know that I'm going to distribute that to every term in the second polynomial. So if I wrote out all my individual terms, which I would recommend doing that, you would get t squared minus 7t, and then minus t to the fifth minus 3t squared. Now, when you have a negative and another negative, because you're distributing this negative and you actually have negative times a negative, that'll create a plus 8t, and then negative 1 times 2 would make minus 2. So again, in some sense, this is your answer, but we have to combine the terms correctly now and write it in descending order. So the biggest term I see is negative t to the fifth. And I've got a lot of students that after they write it in the simplified version and move it to the front, then they'll mark it off just so they don't confuse themselves later on. Then I've got a t squared and a minus 3t squared. That would give me negative 2t squared. I can mark those off. Minus 7t and plus 8t are like terms. They'll give me plus t. And I only actually had one constant term here. It was just a minus 2. So again, this would be the difference of these two polynomials. So just in summary, you drop the parentheses from the leading polynomial, but for the one that has the minus in front of it, you distribute that negative to all the terms of the second polynomial. Then once there's no more parentheses, then you just combine any like terms that you see.